Hello coders! In this video we are looking at an approach to Advent of Code 2022 Day 13 distress signal. In this guide we will be implementing a very simple recursive parser. But don't let the word recursion intimidate you. We will be building up a set of tests that allow you to incrementally implement each recursive function step by step. By the end of this guide, you'll have a working solution for the first part of this puzzle. Although I won't provide a solution to part 2, at the end of the guide, I will give hints and discuss a high-level approach you can use to adjust your solution from part 1 to solve it. I've posted a link to the puzzle in the description below this video. If you get stuck, don't hesitate to post your questions in the comments or make a post on the Advent of Code subreddit. There are tons of people there that are always willing to help. Of course, if you find this guide helpful, let me know by clicking the like button. And if you want to see more Advent of Code guides, be sure to subscribe. And with that, let's get into it. Reaching the summit of the hill, you once again try contacting the elves. Suddenly, the device begins to flash red. You are receiving a distress signal. Unfortunately, you can't make heads or tails of the message. Once again, the device is malfunctioning, causing the packets to arrive out of order. Can you write a program that will reorder the packets? Captain Coder here with Day 13 of Advent of Code 2022. As you just heard, we are receiving a distress signal, but this gosh darn device just won't cooperate with us. Once again, we need to program ourselves out of this problem. That said, let's start by breaking this problem down, understanding what our inputs will be and what our outputs should be. In this puzzle, we are processing packets of information. Each packet is a list containing elements, and each element can either be an integer or another list. This can result in an arbitrary amount of nested lists or integers. For example, if we look at this input, we can have just a regular list here of integers, 1, 1, 3, 1, 1, but we can also have these lists that have lists. So it's a list with a list that has the integer 1 and a list 2, 3, 4. If we look down at this last example, we get some even crazier lists. We have a list that starts with 1 and then has a list that starts with 2, that has a list that starts with 3, that has a list that starts with 4, that has a list with 5, 6, and 7. And then the outermost list has an 8 and 9. And so these lists can have an arbitrary number of other lists inside of them. But what is this asking us to do? We need to compare pairs of packets, so pairs of lists, and determine if the lists are in the correct order. And if we scroll down, we are given a series of rules that defines how a list is compared to another to determine the order. In general, we iterate through the indices of each list, comparing the elements at the same indices. So elements at index 0 get compared, elements at index 1 get compared, etc. down. If we find an element in the first list that is greater than the element associated with it in the second list, that list is out of order. So how do we compare elements? There are essentially 3 different things that can happen. We can have 2 integers, we can have 2 lists, or we can have an integer and a list. The easiest one to reason about is when we have 2 integers. In this case, they're ordered the way we would expect them to be. The integer that's smallest is lower than the integer that's larger. For lists, it's a little bit more complex. The basics of it is that we go item by item, index 0, compare them, index 1, compare them, index 2, compare them, but our lists do not have to be of equal length. If the lists are equal length and we manage to compare all of the values across and all of the values are equal, those lists are considered equal. If we iterate through all the positions in the first list and there are elements left in the second list, then the first list is considered to be smaller than the second list and in the correct position. If we iterate through all of the positions of the second list and we find that the first list is longer than the second list, then we say that the first list is greater than the second list and thus out of order. Finally, if we have one integer and one list, this becomes relatively easy. We sort of promote the integer into a list and then perform a list compare on the two. So let's look at some of the examples they provide. This first pair is pretty straightforward. Both lists happen to contain only integers and we compare them down. First, 1 and 1, they're equal, so we go to the next ones. 1 and 1, they're equal, so we continue. We have 3 and 5. Because 3 is less than 5, it's smaller. This means that the left list is in the correct position. Let us look at pair number 2. In this case, we have two lists. The first element of each list happens to be a singleton list containing 1. So we go and we compare each of those inner lists and we find that 1 versus 1 is equal. So these two lists are equal. Then we look at the next element. We have a list 2, 3, 4 and an element 4. When we go to compare these, the types do not match. So we promote our 4 to a list and then do a compare. So now we're comparing the list 2, 3, 4 with the list 4. We find that the 2 in the first list is less than the 4 and thus in the correct order. Let's look at pair 5. We have a list on the left side containing 4 7s and a list on the right side containing 3 7s. Because the left side has more elements than the right side, this left list is out of order. Next, pair 6, we have an empty list versus a list with a single 3 in it. Because the left side has no more elements to compare, it is in the correct order. Pair 7, we have a list inside of a list that has the empty list versus a list inside of a list that has the empty list. We compare the first element, which happens to be a list with an empty list, and the empty list. The right side ran out of inputs, so we are not in the correct order. And last, we have this very, very nested list here. We compare like elements all the way down, and we eventually determine that this list is not in the right order. All right, with that in mind, what is this puzzle actually asking us to produce? If we scroll down all the way to the bottom, the idea is to find all of the pairs of packets that are in the correct order. We then need to sum up the indices of each one of those pairs. And an important piece here is that the indices start at 1, not 0. Hopefully you have a better understanding of the puzzle, which means we can talk about a strategy. First, we need to decide how we're going to represent our data. In this case, we need to find a way to create a non-homogeneous list in our programming language. Second, once we have defined a data type, we will write a parser that reads in a single packet. Once we have the ability to load in a packet, this will allow us to more easily test the ordering logic that is specified in the description here. And thus, we will begin to implement functions to compare elements of a list. Then, with a parser and a way to compare the packets, the puzzle becomes relatively easy. We parse in all pairs of packets, iterate over them, identify which packets are in the correct order, add that index to a sum. Then, once we've examined all pairs of packets, we report the final sum. All right, let's dive in. First, we need to decide how we are going to represent a packet inside of our program. If we look here, these packets really are just lists. And if your language supports lists, you should take advantage of that. However, this might be tricky because not all languages support non-homogeneous lists. Typically, lists have like items in them because when you're doing data processing, you want to be able to apply the same logic to every piece of data within that collection. In this case, our list can either be an integer or another list. So the item in index 0 isn't necessarily the same as the items in all of the other indices. One way you might solve this in a language that uses classes might be inheritance. You might try to find a class that encompasses both items, a class that can handle lists as well as integers. That is the approach I am planning to take in my solution. I'm using C#, so I'm actually going to use a list of object. Object is the highest level, and object both encompasses int and list of object. If you're in a dynamic language like Python or JavaScript, this won't be an issue. You can just say that it's a list, and JavaScript and Python both support non-homogeneous lists out of the box. If you're in a language like Java, you're going to want to use a list of capital O object, which happens to support the capital I integer class, which is a boxed version of the int primitive type. Finally, if you're in a functional language, you may consider using a union type, which allows you to specify a type that is this or that. To give myself a little sanity check that the data type I've chosen, which happens to be a list of object, is going to work, I'm going to want to write a function here that takes in a list of objects and produces a string. In fact, I want it to produce a string that looks exactly like the strings that are in our example. If I can construct a list of objects that then produce this type of output, I will be relatively confident that I'm going to be able to represent these different inputs. And of course, I've written a test here to help me out. Let's look at these tests. So if I have a list that contains nothing, it should print open bracket, close bracket. If I have a list that contains a single item, it should print open bracket, number, close bracket. If I have a list of just integers, it should print open bracket 1, 2, 3, 4, close bracket with no spaces. If I have a mixed list, I want to make sure that those internal lists also print correctly. And then if I have this sort of crazy nested list, I want to make sure it also prints correctly. So I'm going to recommend you build this up incrementally. First, start by getting this empty list test to work. Then get your singleton list to work. Then get your homogeneous list to work. Then you need to start thinking, how am I going to get my method to take it so if I have a string on the inside, it will convert that string to a list. If you have a function ListToString that's working for homogeneous lists, it's not too far of a stretch to say, hey, can I call this method from inside this method to get my list on the inside? Go ahead, give it a shot, and good luck. If all went well, you now have a set of passing tests and a working method to convert your list of lists to strings. If you're not there yet, go ahead and pause. I'm about to show my solution. Here it is. I take a list of objects and I want to produce a list of strings. This is going to help me because if I have a list of strings, I can easily call the join method that allows me to create a list separated by commas, and then I simply add square brackets on the front and end. To do this, I loop through each object, each element inside of my list of objects, and I check, is that another list? If it is another list, I go ahead and I call my ListToString. So it's going to take that inner list and produce a string that meets the format. And if it isn't a list of objects, I simply tell the compiler, hey, give me that element rendered as a string. Finally, once I have that string back, I add that to my as strings. And as you saw, I simply return the join using a comma separator and square brackets on either side. If all went well, you now have a set of passing tests and a working method to convert your list of lists to strings. If you're not there yet, go ahead and pause. I'm about to show my solution. Here it is. I take a list of objects and I want to produce a list of strings. This is going to help me because if I have a list of strings, I can easily call the join method that allows me to create a list separated by commas, and then I simply add square brackets on the front and end. To do this, I loop through each object, each element inside of my list of objects, and I check, is that another list? If it is another list, I go ahead and I call my ListToString. So it's going to take that inner list and produce a string that meets the format. And if it isn't a list of objects, I simply tell the compiler, hey, give me that element rendered as a string. Finally, once I have that string back, I add that to my as strings. And as you saw, I simply return the join using a comma separator and square brackets on either side. With a data model that we have confidence will work for our input, we're ready to parse that input into that data model. In this case, we're going to write two functions, ParseInt and ParseList. The idea here is that each one of these is going to accept a queue of characters. It's going to be our string, and we're going to process each character once. That method is going to consume characters from the front of that queue until it's able to produce the desired element. To help with this, I have gone ahead and wrote a little helper function here, string to queue, that's going to take in a string and produce a queue of those elements. Not only is this going to help us take our string inputs so we can feed them to these parsers, but it is also going to help us write some tests. First, let's write the ParseInt method. To better understand how this is going to work, let's look at the tests I've written. During parsing, we're going to parse in ints while we're processing a list. So you might find yourself parsing an int when your input looks like this, 689, 85, and bracket. I've used my string to queue method to go ahead and create a queue with this test input. Then I call ParseInt on that queue. The result should be this first integer 689, and then the queue should still have comma 85 close bracket inside. Then I'm going to do another test. Let's imagine we've somehow eliminated this comma, and we're going to parse another int. In this case, I have 85 close bracket. I parse that data, I get the number 85 back, and then the close bracket is all that is left in my queue. The idea here is to be able to process chunks of our input. In this case, we're processing a single integer token. I highly recommend writing yourself a test, implementing ParseInt, and then seeing if you can get it to pass. I hope all went well and your ParseInt method is now working appropriately. If you're not there yet, go ahead and pause. I'm about to show my solution. Here it is. I have my ParseInt. I start off with what I'm calling a token. I set it to the empty string. The idea is that this token at the end of the method will contain an int and I will parse it. The way I do this is I loop checking, is the front of my queue a digit? If it is, I dequeue that character and append it to the end of my string. And of course, at the end, I take that token, parse it into an integer, and return it. Next, to keep things simple, we are going to write a parser for our list that will only parse lists that have integers in them. So we're not going to worry about parsing in the nested list just yet. I've gone ahead and written 3 tests for this. The first test is checking whether or not I can parse an empty queue properly. So if I see an open square bracket followed by a closed square bracket, I should get an empty list back. I'm checking that here. If I parse in a list that has only one element in it, so I have an open bracket followed by an integer, followed by a close bracket. I should get a list that contains just that one integer. And then I'm testing a homogeneous list of integers. If I have an open bracket, a 1 followed by a comma, followed by a 17 followed by a comma, followed by a 6 followed by a comma, followed by a 14 followed by a closed square bracket, I should get a list with each of those tokens pulled out. How can we approach this? We want to use our queue to our advantage. So we have our list here. We're going to start by creating our data model, make it empty. We are going to assume we are getting data that has a list. So we're going to dequeue a square bracket. The first element is going to be a square bracket. We're going to dequeue it. Then we want to loop. We want to say, have I reached the end of my list? If I have, I stop my loop. In this case, if I find a closed square bracket, I'm going to want to dequeue that, and then I'm at the end of my list and I return it. That's going to get your empty list. Inside of that loop, what do we want to do? We know that we're going to be pulling elements, so we want to parse an int. Then we're going to dequeue a comma. Then we're going to parse an int. Then we're going to dequeue a comma while we haven't reached the end of our list. Each time we dequeue an int, we need to add it to our list. Go ahead, write yourself a test, see if you can't implement it, and get that test passing. I'm happy. My tests are passing. Are you happy? If you're not, maybe pause, finish your implementation, and then I'll show you my solution. Here it is. I'm in my parse list. I am accepting my character queue. I create a list to store all of the elements I'm about to parse. I assume that my data is correct, so I go ahead and dequeue the first element because it should be an open square bracket. Then I'm going to loop until I have reached the end of my list. I'm peeking, I'm checking the first element. Is it the end of the list? If it's not, I need to parse an int. I'm going to go ahead and parse my int in, add it to my elements list. Then I check, is there a comma after this? If there is, I'm going to go ahead and dequeue that comma. If there's not, I don't dequeue it, and then I go back up to the top. Am I at the end of my list? If so, I go to the end and I dequeue that last little square bracket before returning my elements. Remember, your parse function should consume all of the characters that represent that piece of data. Now, let's see if we can parse in nested lists. The idea here is to write a method, ParseElement, that examines our queue and decides should it parse an int or a list, returning the appropriate object. Once we have that, we can actually replace this ParseInt with ParseElement, and our list should be able to parse in a list as an element. This is called a recursive parser. Additionally, I've added some more tests so that way when I test my implementation, I know whether or not it's working. In this case, I've written tests that have nested lists, both mixed and lists of lists of lists. Go ahead, write yourself a test, write your implementation, and see if you can't get your test passing. If all has gone well, you are now parsing in nested lists recursively. If you're not there yet, go ahead and pause, but here is my solution. Here is my parse element. It accepts the queue. I'm not going to consume any data right away. I'm gonna peek, I'm gonna look ahead at the first character and decide, is it a digit? If it is, I'm gonna parse an int and return that int. Is it the start of a list? If so, I'm gonna parse a list and return that list. Otherwise, I'm gonna throw an exception stating, hey, something terrible has happened here. I expected an integer or a list, but I found, and then the data that's currently in the queue. Now that we have a working parser, we're going to do something similar to compare elements. First, we're going to write a method, CompareElements, which is going to take in two objects, and we're going to determine whether or not we should compare them as integers or as lists. To help with this, I've gone ahead and created a stub for both of them. CompareList, I'm not going to implement it yet. So in the implementation of CompareElements, I'm going to check, are both of my elements integers? If so, go ahead and compare them as such. The idea here is that I'm going to take two elements and return an integer. This integer is going to be -1 if the first element is less than the second element, 0 if they are equal, and 1 if the first element is greater than the second element. To help with this, I've gone ahead and written a simple test CompareInt. First, I take in two numbers, 100 and 100. If they're equal, I get 0. 50, 75. If 50 is less than 75, I should get -1. And 360 and -50. In this case, 360 is greater than -50, so I should get 1. Go ahead, see if you can write yourself a test for CompareElements that is working on just integers, implement it, get your test passing. I hope you didn't have too much trouble writing this part of the CompareElements method. If you're still working on it, go ahead and pause, but here is my solution. I accept two arbitrary objects, and I'm going to do a pattern match on them in C#. You can do this with an if statement. Essentially, I'm checking, is the first element an integer, and is the second element also an integer? If they are, I'm going to subtract the first element from the second element, and I'm going to use this little helper here that gives me the sign of that element. So it's going to give me a -1 if this value is negative. It's going to give me 0 if it's 0, and it's going to be 1 if the value here is positive. Additionally, if I get a match that isn't an int and an int, I'm going to go ahead and throw an exception, letting me know that I couldn't compare the elements that were passed in. Next, we're going to implement CompareList such that it works on homogeneous lists of integers only. In this case, I've gone ahead and updated my CompareElements to check if I have a list on my left and a list on my right. I call CompareList with the first and second list passed in appropriately. Here is the test I've written here. I'm going to go ahead and parse in the first two packets from our example. To do this, I've written a quick helper which simply takes in a string, calls ParseList, and turns that string data into a queue. This helps me easily test the results. In this case, if I take in this first pair and compare them, I should get -1. The first packet is in fact in the correct location. And to be a little bit more thorough, I've added in two additional tests. This is on the fifth pair, this one here, and the sixth pair, which are also on homogeneous list. The fifth pair should produce a 1 that the first list is actually bigger than the second list. This is because the first list has more elements than the second list. And the sixth pair should be -1, less than the one on the right, because it doesn't have any elements left to compare with the right one, therefore it is smaller. Go ahead, write some tests, write an implementation, see if you can get it passing. If all has gone well, you are now capable of comparing lists that contain only integers. If you're not quite there yet, go ahead and pause. And here is my solution. I've implemented CompareList. I take in two lists, a first list and a second list. I determine what the max index I should iterate to is by taking the minimum of the first and second lengths. I loop through each of those elements, pulling out element 0 and 1. That's going to be the first element and the second element. I call CompareElements to determine the ordering of those two elements. In this case, I've stored it in a variable called diff. If diff is less than 0, I'm going to return -1. If diff is greater than 0, I return 1. Otherwise, I continue looping. If I make it through the entire loop, that means I have reached the end, and I simply subtract the size of my first list from my second list, and I'm going to end up with negative if the first list is less than the right list, 0 if they're equal, and 1 if the first list is greater than the second list. And that's because I'm using this math.sign, which takes a negative number, converts it to a -1, a 0 stays 0, and a positive number becomes 1. And now all that's left to do is finish implementing compare elements. What do we do if we have mixed types? How should we handle that? In the instructions, all we have to do is promote an integer to a singleton list with just that one integer. I've gone ahead in my test, I've added the remaining tests to my test suite. I highly recommend you do the same. You may find that some of those tests that you add are already passing. The ones that aren't passing are those where I need to promote an integer. Go ahead, write your tests, see if you can get your implementation working. Ideally, all of your tests are passing and you are now able to compare packets successfully. Let's have a look. Here it is. I simply check, is the left element an integer? If so, well, I'm going to call compare lists with a list containing just that element and the second list. If only my second element is an integer, I'm going to call compare list with the first element passed in as a list, and then promote that second integer into a list. Then my compare list takes care of the rest. And with all of our components ready to go, we can actually solve this puzzle, or at least attempt to. We are going to take our input and we need to parse it into pairs of packets. We can do this by identifying this double new line here. So this blank line is going to separate that. We're going to separate them, then pull each one out individually. We're going to iterate over each pair, parsing each one into a list of objects and comparing, is the first pair in the right spot? If it's not, if it's less than or equal to when you do the compare, then you're going to add its index to the sum and finally report the sum at the end. One little thing, keep in mind, elves use indexes 1 to represent the first element. Give it a shot. Good luck. If all has gone well, your program is reporting that the example produced the number 13. In this case, that is exactly what we want it to produce. If you're not there yet, go ahead and pause. I'm going to show my solution. Here it is. I read in my file. I split it on 2 new lines. This will split it into chunks that are pairs. I initialize my index to 1. I initialize my sum to 0. I loop over each of my pairs. I split my pairs here on a new line, so I have them each separated. I parse in the first packet. I parse in the second packet, and I call compare list on the first and second packet. If the first packet is less than or equal to the second packet, I increment my sum by my index, then I increase my index by 1. Finally, I report my sum. All that's left now is to download my big input, cross my fingers, and hope I'm one step closer to saving Christmas. I hope you were able to get the first part of this puzzle done using this guide. I'm not going to show a solution for part 2, but let's talk about how you can use this approach to solve part 2. What is part 2 asking for? Part 2 wants us to sort all of the packets we've received and then determine where 2 special packets are inside. Using what you've defined here, you actually have a sort method, the CompareElements method, that you might be able to use inside of your language's built-in sort function. Take a look for it, see if you can find a built-in sort function that accepts a function that takes in 2 values and returns an integer. This is a very common implementation for sort. Once you've done this, you can usually use a function called indexOf, which is going to look inside of a list and determine an index of a specific element. The elements you're looking for happen to be those delimiters. Don't forget that the elves index by 1. With that, I hope you're able to get yourself a working solution to part 2. Hopefully at this point you've submitted your solution and received a beautiful gold star. I hope you found this video helpful. If you did, let me know. Click that like button. If you want to see more Advent of Code guides, click subscribe so you'll be notified when they're uploaded. And as always, have a beautiful day. Keep on coding, keep on growing, and you're welcome back anytime.